In section 1.3, we're going to talk about absolute value equations. An absolute value is the distance of a real number x from 0 on a number line, and we write it as x with these bars over it. So for example, if I'm looking at 4 is 4 units away from 0 on a number line. So the absolute value of positive 4 is 4. What's important to note here is that if we look at negative 4, that's also 4 units away from a number line. So the absolute value of negative 4 is 4. So kind of a simplified way that some people might try to look at this, or at least what I do, is an absolute value, quote unquote, turns a negative into a positive. So it'll keep positive values positive, it'll turn a negative value inside of it into a positive value. So let's look at an example. Here I have the absolute value of 2x minus 1 equals 5. So when I have an absolute value, how I would want to deal with it is I want to split it off. And that's because when I'm dealing with an absolute value equation, it's not uncommon to have more than one solution. So how I'm going to split this off is I want to figure out what its quote-unquote negative solution or positive solution would be. So I want to see 2x minus 1 equaling negative 5 or 2x minus 1 equaling positive 5. From here, I'm going to combine like terms, solve for x as normal. So my first possible answer is x equals negative 2. And then for my positive solution, I get x equals 3. So this might make a little bit more sense when we plug these values into double check. So if I want to check to see the negative 2 is a solution, I'm going to plug it in for x. 2 times negative 2 minus 1 equals negative 5. The absolute value of negative 5 is 5. So that one checks out. On the other side, 2 times negative 3 minus 1 is 5. The absolute value of 5 is 5. So that works out as well. So when I split off, I basically want to see inside the absolute values what's going to give me negative 5, what's going to give me positive 5, because the absolute value of both of those is 5. So here I have two solutions, x equals negative 2 and x equals 3. In another example, we have 3 times the absolute value of x plus 2 minus 1 equals 8. So it's important to note here, which differs from our last problem, is that the absolute value isn't by itself yet. And I can't necessarily split off until that absolute value is by itself. So just keep that in mind before you start solving. So here, before I split off, I'm going to add 1 on both sides. Then I'm going to get rid of that 3. And now I'm left with the absolute value of x plus 2 equals 3. Now, since that absolute value is by itself, I can split off. I want to see when x plus 2 would be negative 3 or positive 3. So my possible solutions here are negative 5 and 1. And if you plug these into the original equation, you'll see that both of these work. Now, I think it's important to double check and plug these in just to help understand, to visualize how these absolute value equations can have more than one solution. But there's also another way why it's important to check. The distance from 0 on a number line cannot be negative. So you might remember that from the distance formula in geometry. If I'm taking a measurement of something or finding the distance between point A and point B, that can't be a negative value. So that kind of goes along the same lines for absolute values too. You can't be a negative distance away from a number line. So some absolute value equations, such as let's say if I saw something like the absolute value of x equals negative 5, that would have no solution because an absolute value will never spit out a negative number. Sometimes when we find answers that would show that the absolute value would equal something negative, we call that an extraneous solution. The formal definition of that is an extraneous solution is a solution derived from an original equation that is not a solution of the original equation. So in those last two examples, when I found two different values from x, there's a lot of times when one of those values won't work out while the other one will. So let's look at one example of that, and that'll be it for today. Here we have the absolute value of 3x plus 2 equals 4x plus 5. I want to solve for x, and I want to check for extraneous solutions. Since that absolute value is already by itself, I'm good to go and I can split it off. So I want to see when 3x plus 2 equals 4x plus 5. and 3x plus 2 equals negative, parentheses 4x plus 5. When I'm checking for that negative solution, remember I want that whole other side to be negative, so it's important to remember parentheses there. So when I solve on the left, combining like terms and everything, that's going to simplify to give me x equals negative 3. On the right side, going through that, I distribute out the negative, combine like terms, and I get negative 1. So my last step here is I'm going to plug in both of those solutions for x to see that they check out. And when I plug in negative 3, I have 3 times negative 3 plus 2, and then 4 times negative 3 plus 5. So now I have the absolute value of negative 9 plus 2 equals negative 12 plus 5, leading me to this. The absolute value of negative 7 equals negative 7. Now there I see an absolute value equaling a negative number. So that tells me that negative 3 does not work as a solution. I would consider that extraneous. Let's check negative 1 to see that that works, because sometimes no solutions work, sometimes just one of them works, sometimes both of them work. When I plug in negative 1, I simplify, and I end up getting the absolute value of negative 1 equals 1. That checks out, so I know that negative 1 is my only solution.